Okay, so here are just a few extra examples to go along with section 10.5, or sorry, 10.7. And I got some new markers, so yay, we'll do some different colors today. This is that first theorem where we have two chords intersecting. So I didn't write this in the video this way, but in class I went over it. That if you know it's inside, it's going to be part times part equals part times part. That's kind of the way I teach it. I don't really go with well, I go with the theorem, but I walked through the theorem, but that's really kind of the way I push it. So part times part equals part times part. Okay. So distribute. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. And then x times x is x squared. 9 times x is 9x. Alright, then we get 4x plus 3x. Well, that's x squared plus 7x plus 12 equals x squared plus 9x. What's going to happen is I'm going to subtract the x squareds in, and they're just going to cancel off. So a lot of times I'm lazy and just know they cancel off. I just mark them off like this before even writing it. And then I got 7x plus 12 equals 9x, so subtract 7x. Running out of room. 12 equals 2x, divide by 2. 6 equals x. Okay. So that's that first example. Next example. This is the other one where we have this guy intersecting outside the circle. So I like to teach this as exterior times whole equals exterior times whole. That's the way I treat it. So my exterior is 5. My whole is 5 plus x. Okay. This one, exterior is 7.5. My whole length then is 7.5 plus 4.5, which is 12. Okay. So distribute 5 times 5 is 25 plus 5 times x, which is 5x. 7.5 times 12 is 84, so it's 90. So subtract 25. 5x equals 65. Divide by 5. X is 13. Okay. Next problem is really our application problem. That's what this one really is going to be for us. We've actually seen a problem similar to this before, where we had it was like a plate that the book gave us in a worksheet we did for a warm-up in class. And what it was is that we knew we had the perpendicular bisector of this, so how could we find the center? Well, we just had to say we'd find the diameter somehow and work with that, because the diameter is the perpendicular bisector. Well, number 5, it says a broken piece of pottery found at an archaeological site is shown. QS lies on the diameter of a circle. What was the circumference of the original pottery round to the nearest hundredth? Okay, well, here's kind of what we have. Well, that's terrible. But either way, we have this part times this part, because again, it's two segments that intersect inside, equals this part times this part. So I'm going to call this x, okay, and I'll say 6 times x equals 10 times 10. Okay, so 6x equals 100, divide by 6. X equals 50 over 3, which is 16 and 2/3. Now I'd say, well, what do we care about that being 16 and 2/3? Well, now I can add 6 to it, and I get the whole diameter, because this segment is the diameter. So the diameter is 22 and 2/3 centimeters, meaning the circumference is pi times 22 and 2/3, which is equal to approximately 22. Well, here's how I have to do it on this calculator actually. Pi times parentheses 22 and 2/3. You have to do is 22 divided by 2/3, or plus 2/3, and so we get 71.21. There's our circumference. Okay. All right, the next example is really an algebra one more than anything. This is the only one we really have any kind of intense algebra with. So it's still outside. Okay, it's still outside. So it's going to be exterior times whole and the whole length's going to be x plus 12, equals exterior times whole, which is really just 12 times 12. So we distribute, we get x squared plus 12x equals 144. Subtract 144 because this is a quadratic, which means I have to use the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is 12, c is negative 144. So x equals the opposite of b, square root of b squared, which is 144, minus 4 times 1 times negative 144, all over 2 times 1, which is 2. So I'm just going to throw this in the calculator real quick. I actually know this is going to be the negative 12 plus this guy, just because of the fact that it's a negative otherwise. So negative 12 plus the square root of 144 plus, well, let's just do it the way it is, minus 4 times 1 times negative 144. I get 14.83 blah blah blah. All that's then divided by 2, and I get 7.42. Otherwise I get a negative number if I subtract it. But distributive property, good old quadratic formula, yay. Alright, last example is the book's attempt at making this a little more complicated than they need to. For this problem, okay, exterior times whole, so what we have, is going to equal exterior times whole. Okay, I'm going to call that y times y. So 5 times x plus 5 is going to equal y times y. Well, the problem is I don't know what this is. However, if I look at it from the right now, exterior times whole, which is 14, is going to also equal exterior times whole. So really, by the transitive property, these two guys are equal because they're both equal to y times y. So 5 times x plus 5 equals 7 times 14. 5x plus 25 equals 98. Subtract 25. We end up getting then 5x equals 74. Divide by 5. X ends up being, oh, what's that? 14.8. Oh, I ran out of room. So there you go.